Okay, continuing with example 3. It says use the point P with coordinates 0, 1 to determine the values of sine 90 degrees, cosine 90 degrees, and tan 90 degrees without a calculator. So let's start with a bit of a sketch here. So point P has the coordinates 0, 1. So we'll mark point P on the y-axis. And so this would be my terminal arm right here. So you can see then that the angle associated with that terminal arm is a 90-degree angle. So we're asked to find values of sine 90, cos 90, and tan 90 without a calculator. Now notice in this picture, there's no triangle in this question at all, because of course point P is right on the positive y-axis. So what we do know though is that the length of R is 1. In other words, the distance from point P to the origin is 1, given the location of point P. We also know that x is 0 and y is 1. So then we can use our formulas to find those values. So sine 90 will be y over r, 1 over 1, or just 1. Cos 90 will be x over r, so 0 over 1, or just 0. And tan 90 is y over x, which would give us 1 over 0. And of course, when you try to divide by 0, that doesn't work. So tan 90 is undefined. All right, moving on to example 4. Example 4 says, point F with coordinates 5, 3 is on the terminal arm of angle beta. Find the primary trig ratios for angle beta. All right, let's go ahead and mark off the point 5, 3. There we go. So this is angle beta right here. All right, so we know that x is 5, y is 3, and we can use our formula to find the length of r. So r will be equal to the square root of 5 squared plus 3 squared. R is equal to the square root of 34. And we will leave that in exact form rather than changing it to a decimal value. So now using our formulas, sine beta will be y over r, so in this case 3 over root 34. Cos beta is x over r, or in this case 5 over root 34. And tan beta is y over x, or in this case 3 over 5. So there we have the 3 primary trig ratios for angle beta. Now the next part of this question asks us to find the coordinates of the endpoints of the terminal arm for each angle. The first one is 180 degrees minus beta. So let's think about where that would be. If beta is an acute angle in quadrant 1, 180 degrees minus beta would have its terminal arm in quadrant 2. And if we reflect the point F across the y-axis, we would have a point on the terminal arm of the angle 180 degrees minus beta. So there we would have 180 minus beta right there. So the coordinates of a point on that terminal arm would be negative 5, 3. Okay, the next one says find the coordinates of the endpoints of the terminal arm for the angle 180 degrees plus beta. Well, 180 degrees plus beta would have a terminal arm in quadrant 3. So again, I'm going to reflect the point F, this time through both axes, and I will plot a point at negative 5, negative 3. So this would be, the one I'm marking in red, would be the angle 180 degrees plus beta. And a point on that terminal arm would be negative 5, negative 3. Now we'll grab one more color here for the last one, which is 360 degrees minus beta. That angle would have its terminal arm in quadrant 4, and by now I think you see the pattern happening here. A point on that terminal arm would be 5, negative 3. So this would be the angle 360 degrees minus beta. Now in the chart that follows, we're asked to determine the primary trig ratios for each of those angles in part B and complete the table to compare the trig ratios for the 4 related angles. So what we're going to do is list those angles in terms of beta, because we actually still don't know its sides. So we're going to just write the angles in terms of angle beta in the left-hand column. So our 4 angles are beta, 180 degrees minus beta, 180 degrees plus beta, and 360 degrees minus beta. And we want to fill in the sine, cosine, and tangent ratios for those 4 angles. Now, we've already done those ratios in part A for angle beta, so we can fill those in here. We said that sine beta was 3 over root 34. Cosine beta is 5 over root 34. And tan beta was 3 over 5. So then we can go through and do the same thing for the related angles. Now for the next one, 180 degrees minus beta, remember we said that a point on that terminal arm would be negative 5, 3. So for this one we'll have x equals negative 5 and y is equal to 3. And of course the length of r doesn't change. All 4 of those terminal arms would have the same length. So sine 180 degrees minus beta would still be given as y over r. So in this case it would be 3 over root 34. Cosine is x over r, so that would be negative 5 over root 34. And tan would be y over x, so in this case 3 over negative 5. Now for the next one, 180 degrees plus beta, the values we'll use for x and y come from the point we developed in part B. So x is negative 5 and y is negative 3. So now if we go through, the sine ratio then would become negative 3 over root 34. The cosine ratio would be negative 5 over root 34. And the tangent ratio would be negative 3 over negative 5. So we can simplify the negatives and leave that one as 3 over 5. And lastly, we have the angle 360 degrees minus beta. And for that one, we're going to use the point 5, negative 3. So x is 5 and y is negative 3. So the sine ratio becomes negative 3 over root 34. the cosine ratio, so x over r, becomes 5 over root 34. And the tangent ratio, y over x, becomes negative 3 over 5. So if we compare these sine, cosine, and tangent ratios, what you should see is that in each particular case, for the sine ratio and the cosine ratio and the tangent ratio, they're all the same for these related angles. The only thing that changes is the sign of those ratios. So the sine ratio seems to be 3 over root 34 in each case. For the last two, it's negative, and for the first two, it was positive, and so on and so forth. And this leads to an important result called the cast rule that we're going to talk about at this point, which helps us to determine which ratios are positive for a given angle, and that depends on which quadrant the terminal arm lies in. So let's have a look at that. Okay, so what the cast rule tells us is that in quadrant 1, for example, if we start there, if I had an angle whose terminal arm was in quadrant 1, no matter where I chose a point on that terminal arm, the coordinates for that point would both be positive. So no matter where I plot a point in quadrant 1, x will always be positive and y will always be positive. So they're both greater than 0. If x and y are always positive, and by the way, r will certainly always be positive because r is the distance from the point on the terminal arm to the origin, or the length of the hypotenuse in the associated right triangle. So in no case will r ever be negative. So if I'm dealing with all positive values for x, y, and r, then that means sine, cosine, and tangent will all be positive. So we're going to say here in quadrant 1, all ratios will be positive. Okay, because again, no matter where we put a point in this quadrant, x is always going to be positive because we're talking about the positive x-axis, and y is always going to be positive because we're talking about the positive y-axis. So all ratios will be positive, and we're going to mark that with an A. Now in quadrant 2, the y-coordinate will still be positive for any point marked in that quadrant, so any terminal arm in that quadrant. And x, though, will be negative. So let's say here, x is going to be negative, and y is going to be positive. Now let's remember here the formulas that we're using for sine, cosine, and tangent. So sine theta is y over r. Cosine theta is x over r. And tan theta is y over x. So we just said that in quadrant 2, x is negative and y is positive. So if y is positive, and we know r is positive, sine is going to be positive. Cosine, though, is going to be negative, because cosine theta is defined as x over r, and if x is negative, then the cosine ratio will be negative. The tan ratio will also be negative, because tan theta is defined as y over x, and again, if x is negative, then the tan ratio will be negative. So the only one that's going to be positive in quadrant 2 is the sine ratio. So we're going to say here, therefore, only sine is positive, and we're going to mark that quadrant with an S. Please refer now to part 3 of this video lesson.